let's take a look at this example. We once again want to find the critical points and use the second derivative test to determine relative extrema. Our function here is labeled g of x. We take the first and second derivatives. The first derivative is 3x squared minus 12x plus 12. The second derivative is 6x minus 12. In order to find the critical points, we first find the critical values. The critical values happens when the first derivative is 0. So we can set 3x squared minus 12x plus 12. We can solve that, divide both sides by 3. You end up with x squared minus 4x plus 4. Now that has a factoring on the right-hand side of x minus 2 times another copy of x minus 2. So the critical value happens only at x equals 2. So we have one critical value happening at x equals 2. Let me find the critical point that corresponds to the x value of 2. We would plug in 2 into our original equation. 2 cubed minus 6 times 2 squared plus 12 times 2 plus 9. I ended up with 17 as the corresponding y value when we plugged in an x of 2. Again, plugging that into your original function, g of x. Now, let's use the second derivative test to determine whether or not we have a relative minimum, a relative maximum, or unknown at an x value of 2. Well, in this case, if I plug in an x value of 2 into the second derivative, we get a 0. That means this is not going to be something that works on the second derivative test. The second derivative test is not working here. If the second derivative test doesn't work, then I can go on from there and figure out what's happening by utilizing another test. I could either look at the graph or I could use the first derivative test. If you look at the interval from negative infinity up to 2, plug something into the first derivative that's within that interval. Let's plug in 0. Remember, the first derivative is 3x squared minus 12x plus 12. So the first derivative, when I plug in 0, gives me 12. That means from negative infinity up to 2, my function is increasing. Now from 2 all the way to positive infinity, what's my function doing? Let's plug in a value of 3. When I plug in a value of 3, again into my first derivative, 3 times 3 squared minus 12 times 3 plus 12 gives me a positive 3. So the second derivative test failed. The first derivative test says at 2, we go from an increasing function to another increasing function. That means that this point, the point 217, is neither a relative maximum nor a relative minimum. If you look at further what's happening, notice that by plugging in 0.2 into my second derivative, I got a 0. That is indicating, since we're going from increasing to increasing, we have a continuous function, and plugging in 2 gave me 0. That actually tells me that we have an inflection point there. So if I put together a few ideas, second derivative being 0, going increasing, and having a continuous function means we have an inflection point at the point 217. So in this case, we got one critical value, and it was at an inflection point. I would like you to try this problem on your own. Push pause on the video, try it, and then watch the next video for the solution.